everyone, welcome to another video. This is part 16 of my Gateway API for Kubernetes series. I actually didn't plan to make this video, but last week I got a couple great questions and comments on my videos, so I thought I'd just make a video and try to answer all of them. Today I want to talk about two different topics. First, I want to clarify some things about the Envoy Gateway API. And then I want to show you how we can even more automate the creation of our certificates using the Cert-Manager. After a quick introduction, I'm going to show you everything in a demo. So let's get started. About the Envoy Gateway API, one of the questions was if we can use it the same way as other gateway APIs, for example, if you have the same resources, and the answer is yes. So in the beginning of this video series, I showed you the Azure Application Gateway for containers. This is just a gateway API implementation from Microsoft, but any other gateway supports resources like the gateway itself. Then we have a gateway class or other resources like the HTTP route. The only thing that does not work if you have an in-cluster gateway API like Envoy or Nginx is the Azure specific integrations. In one of the videos, I showed you how we can integrate the WAF, the Web Application Firewall, with our application gateway because we use the Azure Application Gateway for containers. Therefore, it was able to link them. But if you have it in cluster, this doesn't work. But everything else works the same way as it works with any other gateway API. So today I'm going to show you again how to install the gateway API and then how we can access a demo application through the HTTP route, and we're also going to use the Cert-Manager to create a TLS certificate. This means we're able to use HTTPS with our Envoy Gateway API. Then the second question I got was, how can we even more automate the creation of TLS certificates with the Cert-Manager? This was an oversight on my side. So in the video I showed you the Cert-Manager, and we created a certificate manually. And after this, the Cert-Manager created the request to Let's Encrypt and then created the TLS certificate and the secret. But we can automate this even more. This means creating the certificate object is optional. If you have one specific setting, this is having the name of the cluster issuer as an annotation of the gateway. And once you have this, you don't need the certificate object anymore. So if you take a look at the gateway, so we can see here this annotation. It's fully called Cert-Manager.io ClusterIssuer. And if you add the name of the cluster issuer, then you don't have to create the certificate object. Here you can see the certificate object. There we told it what is the name, in what namespace do we want it, what's the name of the secret, and so on. And we don't need any of this, as long as we have the annotation set. In my video back then, I already had the annotation set, so we didn't need to create this certificate object. The reason why it works is once you have this annotation, then the Cert-Manager knows to check the gateway, and the way it does this, it checks the listeners for TLS secrets. So if you have a TLS secret configured there, then the Cert-Manager will automatically create a certificate for this listener. The way it works is here we have a listener for HTTPS of our gateway, and down here we have this TLS section. Here we say we have a secret and we provide the name of the secret. That's all it needs for the Cert-Manager to automatically pick it up and create a certificate for us. But now let's switch over to the terminal. Let's deploy everything, and then I hope it is clear how it works. Here in the terminal, let's define a couple variables first. So this is going to be the name of my AKS cluster, the location, and the resource group. If you have seen the last video, then we already have an AKS cluster, and we also have already Envoy deployed. So you'll find the chapters down below and you can just skip this part. But for now, let's also define the variables for the gateway namespace, the name of the gateway and the gateway class. Then we have the namespace for the Cert-Manager and the name of the ClusterIssuer. And as last part, we have some information about our demo application. So this is going to be the namespace, the name of the HTTP route, the name of the app, the secret name, and the URL. So this is everything we will need. So let's clean this up, and now we can create our AKS cluster. So first we create the resource group with the name and the location we provided. Then we're going to deploy our AKS cluster, again with the name and the resource group. This will now take around 5 minutes. And as always, the code I show you today is in the description down below, so you can just download it from GitHub. You don't have to type anything, you just can copy it and paste it from there. And as I said, it will take around 5 minutes, so I'm going to stop the video here and we will continue once the cluster has been deployed. Our cluster has been created. Now we can just download the credentials and are done with the setup. Next up, we are going to deploy our Envoy Gateway API using the Helm chart. We are going to deploy it in its own namespace, and we're also going to create the namespace during the deployment. This should only take a couple seconds, but as I said before, if you followed the last video, you already have this set up, so you can just skip the parts and find the chapters down below. There it is, our gateway is deployed, and if we now take a look at our gateway, then we can see we don't have any, and if we take a look at the gateway class, we can also see we don't have any. This means we have to create them first. So let's now create a gateway class. So here just provide the name of our gateway class, and then we can say that our controller is the Envoy proxy. Then we're going to apply this variable. Our gateway class now has been created. Next, we're going to create our gateway. So let's clean this up. Paste the gateway. If you take a look, it's very basic. So we have just a name and namespace. Then here's the important part for the Cert-Manager. This means we have one annotation, and there we provide the name of our ClusterIssuer. Then we have two listeners. First, we have one for HTTP that allows routes from all namespaces. And then we have one for HTTPS. I just call it traffic because my demo app is traffic. Then we have a host name, that's the URL. This URL will be used later to access it over HTTPS. And on the bottom down here, we have the reference to our TLS secret. And thanks to this configuration, the Cert-Manager is able to create the certificate automatically. So we don't have to do anything else. Cert-Manager will take care of everything. Then let's apply this gateway. It can take 1 or 2 minutes until everything is set up, but if we take a look now with kubectl get gateway, then we can see it's already set up. So we have here a public IP address because I'm using Azure, and if I have a load balancer service, which the gateway API is, Azure provides a public IP address. And what's important is that the programmed state is set to true. This means everything worked and we have no configuration issue. If we now take a look at our gateway class, we can see the same. Here it's called accepted, but it's also set to true. This means we have the link from the gateway to the gateway class. What we could also do is we can query the IP address from the gateway and save it in a variable if that's what we want to do. But today we're using the URL, so we only need this IP address to configure our DNS. And that's what we're going to do next. So I'm copy this IP address and switch over to the Azure portal. Here in the Azure portal, I already opened my DNS zone. And here you can see we have the entry for traffic with an old IP address. So we're going to update this IP address. Let's just copy and paste it or replace the old one. We save it and that's it. Usually that's something a pipeline would do, or you would do it with the CLI or any other tool. But for the demo, I want to try to keep it as simple as possible, so the Azure portal is fine. Now let's switch back to the terminal and install our Cert-Manager and ClusterIssuer. Back in the terminal, let's add the Helm chart for the Cert-Manager and also update it. Then we can install it. So I'm just gonna install it, and let's take a look while it runs. So here we provide the same namespace as before. I just forgot to use the variable. The most important setting we have here is this line. So we configure that we use the gateway API. This means Cert-Manager now knows to check our gateway. Here you can see it's already finished. It only takes a couple seconds. And with this setup, we can now create our ClusterIssuer. So I'm just gonna paste this here. As we can see here, we have the same name as we have configured in the gateway API. Then we have here two endpoints. One is for staging and one is for the prod environment. So when you set it up the first time, I would recommend using the staging environment. And once you know what you're doing or you have tested it works, then you can use the prod one. I'm using the prod environment here. Then down here for the solvers, we just tell it we have a gateway, we provide the name and the namespace. This means our ClusterIssuer has now the link to the gateway because we also have the annotation on the gateway. If you want more details about ClusterIssuer Cert-Manager, take a look at the playlist down below. I'm explaining in a previous video exactly how everything works, but for now I just want to deploy it and show you how we can use it without going too much into detail. So I'm going to apply this ClusterIssuer. So it has been created. If we now take a look at our ClusterIssuer, we can see it's exactly the configuration we had before. And also we can see here the status is true and the type is ready. This means everything worked. We can also see here the Acme account was registered and no error message. So everything should work now. To test if everything works, let's now deploy a test app. So I've already prepared one. I'm just going to paste it in here. Then we're going to take a quick look. So I'm going to create a new namespace. Then we create a new deployment. And as the container, I like to use the traffic who am I because it gives some basic information. Then we have a service of type cluster IP because we want to access our application through our gateway API. Therefore, cluster IP is fine. And that's already everything we need. So we're going to deploy this. And while all these resources are being created, the last resource we need is the HTTP route. So I'm going to paste this here. With the HTTP route, we have the link from our gateway to our application. So it tells the gateway how to route our traffic. So here we provide the namespace where we have it deployed. Then we have the reference to our gateway with the name and the namespace of the gateway. Then we provide the host name. So this is the URL we want to use to access our application. And then we can configure some routing rules. Here I just use it. I keep it as simple as possible. So I just route everything to my service and I'm using port 80 because the TLS termination will happen at the gateway. This means I have HTTPS to the gateway and then inside the cluster I'm using HTTP. Let's also apply this. Actually, let's create the variable first, then apply it. Now let's take a look if everything has been created. So if here our ClusterIssuer with an internal IP address, we have our deployment, it's running. So everything looks good and we should now be able to test it. One last thing. If something doesn't work, it's always a good idea to take a look at the gateway. And you can do this with kubectl describe gateway, provide the namespace. And here you can see everywhere it says the status is true, it's accepted, the listener has successfully, I guess, translated maybe. So everything is great, no error message. And also on the way down here, we see here the create certificate event. So this happened not even 5 minutes ago. And it says successfully created certificate, traffic, let's encrypt secret. So we didn't have to do anything for the certificate. It has been automatically created. And this again, because we have the annotation on the gateway. So everything looks good. Now let's test it. We can just do a simple curl. We're using HTTPS and our URL. Here we can see we get HTTP 200. So everything works as expected. We have here our URL. That's the traffic.programwithwolfgang.com, what we configured before. And we can see here our pod is the traffic deployment. That's the one from the test app we just deployed. If you open the URL in the browser, we can see it also works. We also see some information like the host name. And if you click on the certificate, then it says the connection is secure. So we don't have an error message or warning here. If you open the certificate, it says it's valid. It's created from Let's Encrypt and it is valid for 3 months. We don't have any warnings because we created the certificate ourselves. So it's full production ready and ready to be used. That's already everything I wanted to show you today. So today we have seen when we use Envoy as our gateway API, we can use it the same way as we can use any other gateway API controller. This means we have our gateway with our gateway class. We could create a HTTP route, and through this setup, we were able to access our test application. We also deployed the Cert-Manager. Then we set the annotation with the name of the cluster issuer on the gateway, and also created the cluster issuer itself. This setup allows us, or the Cert-Manager, to create certificates automatically without any intervention or any action from our side. This means we don't have to create a certificate, a secret. Everything is done automatically. It takes 1 or 2 minutes usually, but after this we have seen we were able to access our test application using HTTPS, and we also had a valid certificate. This means a full production ready certificate, automatically created and for free. I hope this was useful. If you have any more questions or ideas for new videos, let me know in the comments below, and I hope to see you next week with another video.